Wow, this is a busy, difficult-looking question on first glance. Always start here. Which of the following objective functions? Well, the objective would be to maximize profit. We do that by maximizing contribution. And constraints. Something that it's a constraint means we don't have enough material, we don't have enough labor to make everything we want. I'm going to show you how to do it quick, and then I'll take you through it in more detail. Well, first of all, a constraint is less than or equal to. All of these numbers are the same in the answers, right? So that's not what's different. The difference is the sign. Less than or equal is what we want. So the answer has to be A or C. Now we're left with this. 60x, 25y, 15 and 12. We're looking for contribution. So that's the contribution per unit. Now I start reading and I see the selling price is 60 and the other selling price is 25. Can't be selling prices, has to be contribution. So by elimination, we made a very difficult, quick-looking question quite easy. Now, let me take you through this in a bit more detail, if you'd like a little bit more background here. Okay, so we need to find contribution per unit for the objective functions. Can we do that? Sure, we can. We've got selling prices. We've got variable costs. Got to make sure there's no overheads, fixed overheads in there, and there aren't. Okay, so 60 minus 45, that's the 15. Okay, 25 minus 13, that's the 12. Okay, so we can get the objective function fine. Now, what's going on here? Well, x and y, right, that's about the product that we're making. And that number in front of it, that coefficient, is actually about units. It's not a monetary value here. And look at this. The cost per unit is 15. The price per kilo is 5, so 15 divided by 5 is 3. It takes 3 kilos to do an X, and it takes 1 kilo to do a Y. Same thing with the hours. Look at that. $24 divided by 6 is 4. 3 divided by 6 is 0.5. That's where we get the 3 and the 1, okay? And the 4 right there, and the 0.5. They could make this question a bit trickier. They could start sprinkling in the wrong coefficients in some of them, right? They could give you a 15 and a 24 instead of the 3 and the 1. So there are ways to make this more difficult. Oh, and then of course we have this. That's the maximum that we can use. So we only have 4,200 kilos. And 3,000 labor hours. So guys, there's a deeper dive into the question and the correct solution. Here's a tricky one. If an extra 20 kilos of material becomes available at a selling price of $2, what is the maximum increase in contribution we get? Well, this is a spin on our limiting factors. Here we're looking at shadow price. Let's go through this together. A linear programming model has been formulated for 2 products. The objective is C equals 5x plus 6y. That would be contribution per unit for each product. Okay? Each unit of x takes 2 kilos of z, and each unit of y takes 3z. Now check this out. The standard, this is important, the standard cost is 2. How much are we paying? Are we paying the standard cost? Yes, we are. We are paying the standard cost of 2. So there's no increase in price. We're not paying a premium to get more units. Shadow price, guys, is simply the incremental contribution we get from one more input, one more unit of input. Shadow price is 2.8. That means every time we put another kilo of Z into my production, it's going to crank out 2.8 in contribution. Now look at this. I'm paying the normal price. I'm not paying a premium. Shadow price tells us the maximum extra price we would pay on top of the 2. So we're going to keep all of this extra contribution. So 20 times 2.8, okay, that's going to be 56. Answer, everybody, is B. Here's a classic question. Set a production plan when we have a single limiting factor, and we do this by focusing production on maximizing contribution per unit of scarce resource. So, do we know anything that is scarce? Labor hours are scarce. And they ask us, what is the order of production? In what order should we produce the products? Well, the trap that we see over and over again, they give us profit, but we need to work with contribution. It's these absorbed fixed overheads clouding our judgment. It doesn't matter our production plan, the overheads will stay the same, so we work with contribution. And we can just add the fixed costs back to the profit. We could subtract variable cost from selling price, or just add fixed cost back to profit. The latter is faster, so we would have a 46 contribution, we would have a 52 contribution, we would have a 21 contribution, we would have a 60 contribution. Now we have some labor hours here. So if we wanted to do contribution per hour, we would then divide the 60 by the 2. We would get 30 over here. We'd get 7 over here. Remember, this is contribution per labor hour. We get a 6.5 over here for B. And we get a 7.6 for A. And we want to maximize our contribution per unit of scarce resource. So the first thing we'll do, we'll make the D's. Second thing we'll do, we'll make the A's. Third thing we'll do, we'll make the C's, right? We're going in a descending order of contribution per labor hour. The last one is B, the smallest number there. Okay, so there you have it. Contribution per labor hour, helping us set our production plan. And the answer, everybody, is A. Okay, we could have gotten that also using some exam technique. As soon as we got to A as the second one, we would have been able to eliminate and get the right answer. Here we are looking at multiple scarce resources. So we're using the linear programming type of solution to solve this problem. And slack resource, that means we have extra resources after we set our production plan. So we didn't use up all of the labor or machine time. And how do we figure out which is slack? Well, the jewelry company makes 2 products, R's and N's, and we have the constraint equations. Remember, that's not a monetary value. That number in front, that coefficient, that is the units. That's the labor hours and the machine hours, okay? So it's just a quick check. If we're going to make 500 rings, 400 necklaces, well, 500 times 3 is 1,500. 400 times 2 is 800. Okay. So 1,500 plus 800 equals 2,300. Guys, we have enough left over because 2,400 is our maximum. We're only using 23. Let's check for machine time. 500 times 0.5 is 250 hours. 400 times 0.4 is 160. Okay, that equals 410. So we don't have any leftover machine time, but we do have labor hours. So it's labor time that is our Slack resource. Answer, everybody, is A.